Good afternoon. I'm Dr. Donna Guerin, Executive Vice President of Science and Policy at the American Frozen Food Institute. Welcome to today's webinar, the fourth in the Sanitation Controls track of AFFI's Food Safety Webinar Series. During today's presentation, we will explore the importance of freezer sanitation. This afternoon, we are delighted to have Dwayne Grassman of Nestle USA with us to provide his insights. Allow me to give a brief introduction of Dwayne and his background. He has made food manufacturing, sanitation, and hygiene his primary focus over the past 42 years. He has worked with countless factories in the United States and Canada, including significant hygiene-related involvement in hundreds of factories' engineering projects. In the last 12 years, he has held corporate roles in quality management at Nestle USA and the Schwan Food Company. Prior to these corporate positions, he worked for 30 years with numerous companies in various sanitation management positions. Before we get going with today's presentation, I'd like to turn it over to Sarah Brandmeier, AFFI's Manager of Scientific and Regulatory Affairs, for some housekeeping information.
Thanks, Donna. So we will not be answering questions until the end of this webinar. However, throughout the webinar, you may write your questions in the text box on your GoToWebinar control panel, and Donna and I will read them aloud during our Q&A session. Also, this webinar is being recorded, and the recording and presentation slides will be distributed to all of the registrants of this webinar. Again, we are excited to have Dwayne with us today, and with that, I will turn it over to you, Dwayne.
Perfect. So thanks, Donna. Thanks, Sarah. I know Sanjay is back there lurking somewhere. I appreciate the introduction and the opportunity to spend some time with this many people talking about freezer sanitation. So before we get started too far, I just want to say that in the 30 years that I got to work in factories as sanitation manager, sanitation supervisor, a sanitarian, a sanitation lead man, a third shift manager on duty for all these companies and all these different factories making all kinds of different product. You know, and when I get to thinking about it, that really means that I can't seem to hold a job. But anyway, I am now the culmination of a lot of people sharing their brilliance with me. So lots of smart people telling me things. I remember some of them and go around repeating what these smart people have told me, and then I get credit for being smart. It's a really great gig if you can get it. So I don't think of a whole lot of new things, but a lot of people have shared with me a lot of really good stuff. So it's my pleasure to spend some time trying to share with you things that might help you to make better decisions than you already are making. So one of the themes you'll hear throughout this is, that I've made a lot of mistakes, for one thing, and done it the wrong way. So what I want to do is try to help make sure that you don't make the same mistakes that I made. So don't be a big old Dwayne is going to be kind of a redundant theme through this. So let's get on with, I've got 214 slides to go through, so I think we should be able to make it by supper time. No, that's not true. I've actually got 15 slides and we're already on slide 2. Okay, webinar objectives. So one thing I'm not going to cover is how to manage your specific freezer and your specific application. If you came to this webinar with hoping to find out exactly how to manage your freezers, I'm going to very badly disappoint you. Instead, I want to offer up some guidelines as to how to make good decisions and have guardrails around that. So frameworks within which to make your own decisions based on your application and your specific freezer. So here's the things I want to get through. I want to talk about where to get more information. We're going to talk about reducing risk. So what our sanitation objectives really are. Environmental pathogen monitoring and controls, we could talk for a month on that, but we're going to try to cover some of the high points in dealing with sanitation of your freezers. Watch outs, there's lots of watch outs when it comes to freezers. I'm going to hopefully get to some next steps, things that I would encourage you to do, and then summary and Q&A. So, more information. The fact that you're on this webinar means that you're smarter than I am. Because when I was coming up through factories, I did not know where to get information. It was a little harder to come by, but I thought I knew everything I needed to know. That's being a big fat Dwayne. Don't do that. By virtue of the fact you're on this call, you know that there's more information than what you have. AFFIFoodSafety.org has got this Listeria control program that is absolutely fabulous. They pulled together so many incredibly smart people, and then they invited me. Anyway, these smart people put together best practices and guidances in a whole bunch of different categories around keeping Listeria out of your factories and dealing with Listeria that's prominent in frozen food factories. So all you got to do is fill out the request form, and you're going to get access to the documents for free, and they'll email them to you. So you get, electronic copies for free. Did I mention it's free? This is fantastic. So go to AFFIFoodSafety.org, look at the Listeria control program, and spread the word. Spread the word. That's, I think, really important, so that there's fewer of those big old Dwaynes running around who think they know it all but actually don't know anything. Okay. Oh, and by the way, in the bottom right-hand corner of my slides, I'll try to, put something in white font that will give you some more information. All right, why are we concerned about freezers? Well, might have to do with it's the American Frozen Food Institute. Really, there's a lot of reasons. One is history. There's just a little bit of history about Listeria being in freezers. That's facetious. There's a lot of history here. We all know that it's a high-risk situation. So these freezers are notorious for having Listeria. They're complicated pieces of equipment. They've got some serious design problems. They're big, they're bulky, there's a lot of stuff going on inside, they're hard to clean, it's really hard to see things in there, they're hard to maintain. So this complexity is a driver behind some of this history. Another is that they're really expensive. $250,000 doesn't get you much in the way of a new freezer. They're very expensive pieces of equipment. They're also very complex. This drives them to sometimes, we run them a long time. They're oftentimes old. So I've had people say, geez, our freezer's 30 years old. It's rusty, it's cracked, it leaks. I'm thinking, I'm pretty old and I even have some of those same problems. But old is not, I can't believe I said that. Okay, first and last AFFI webinar. Anyway, old is not bad. Old is okay, actually, as long as it's not neglected. If you're old and neglected, things are going to be ugly. So we want to make sure that we talk about that. So these are our concerns about freezers. Sanitation objectives for freezers. This is kind of interesting because when I was coming up through the factories and working in all these different companies, I didn't really know why I was cleaning. So sometimes I'll go into a factory and they're struggling with cleaning a piece of equipment, and I'll ask them, why are you cleaning it in the first place? And it can be anything of a response from a blank stare, like, geez, I don't know, to, geez, Dwayne, we heard you quit smoking crack. I didn't know why I was cleaning other than the fact that it was time to clean. It's third shift. We always clean on third shift. That's why I'm cleaning. I really didn't have a good objective. And if you don't know why you're cleaning, it's really hard to understand how clean am I supposed to get it? Because when I had my cleaning crew out there, we cleaned because it was time to clean, and we stopped cleaning when it was time to stop cleaning. It wasn't necessarily to some type of an objective. This was kind of a big mistake. I had a lot of variability in the outcome of the cleaning that was being done. And variability is not a good thing to have in cleaning outcomes. It's actually kind of career limiting. And if I didn't know why I was cleaning or how clean to get it, it's kind of difficult to determine how unclean I can let it get before I have to re-clean. See, there's this window that we need to be cognizant of between the condition we leave it when we're done cleaning and the condition it gets into over time that makes it necessary to re-clean. With freezers, this is kind of an important thing because the last thing we want to do is clean freezers more than necessary, because cleaning is really hard on freezers. And we're going to talk more about that a little later. So why are you cleaning your freezer? You need to have that. And then how clean to get it, and then how unclean can you let it get? These are some important concepts I would encourage you to have. I would really encourage you to have that cognizant, intentional discussion. Lots of smart people in the food industry, and Nestle has managed to accumulate and retain some really, really smart people. And one of those people I really respect has taught me a way to look at risk that just clicks with me. So I want to share it with you. Cleaning to reduce risk. This is probably one of the major reasons we want to clean. I mean, there's other reasons, but when it comes to Listeria and freezers, really the major reason is to reduce risk. But this doesn't really necessarily only apply to freezers. Really, it can apply to all cleaning. So here's the equation that this person I respect a lot shared with me. It's an interesting way to look at the hazard, the risk, the severity, and then our ability to deal with that. So it's this math. I liked math when I was in school. I did okay at it. I can math, and that's actually using it as a verb. I know that if I want to reduce the value of a fraction, that I need to decrease the top number, the numerator, and or increase the bottom number, the denominator. So if I can do that in this equation, I can reduce my risk. So the top part, though, is difficult. It's really hard to reduce the hazard of concern, the vulnerability, and the exposure. It's not saying that we shouldn't try, but there's some intrinsic risks that are difficult to influence. It's not the low-hanging fruit. So, for example, the insulated panels in your freezer, there's very little alternative to having those, but they are a risk. Once those things get saturated and contaminated, it's really hard to deal with, and there's virtually no real good alternative. Our vulnerability. Now, so vulnerability to me is like if I live on the coast in Florida, I'm vulnerable to a hurricane. If I live in Fargo, North Dakota, I am not vulnerable to a hurricane. So there's this potential for failure in our freezers, and it's accentuated by the type of product, for example, that we run through, unwrapped versus wrapped. So if we've got wrapped product, okay, our vulnerability is a lot lower that the freezer is going to cause a contamination of our finished goods. So why don't we just wrap all the product? Well, because that really is hard to do. I mean, it changes the thermodynamic process. We have to put the wrapper on the other side of the freezer. Yeah, not something we're going to probably do. And then do we have a RTE or a not ready to eat product going through the freezer? Those are some serious exposures that we've got. So all of these things we can strive for, but I think we're probably smarter going after our capacity to cope. That reducing that or increasing that denominator, increasing our ability to reduce that risk, but the question becomes how. Now, in my limited intellect, I can think of three things that are pretty apparent in how to increase our capacity to cope, to reduce our overall risk. So if we make a good investment and improvement in cleaning, sanitary PMs, and our hygienic design, these three topics I want to cover individually. So this is what's going to increase our capacity to cope. So let's start with the cleaning. If we've got effective cleaning, we're going to have a much better day at the office. But what is really effective cleaning? It's following a procedure that's under control to get us a predictable and repeatable success. So FoodSafetyMagazine.com published an article for me. That was a foolish thing for them to do, but this article I wrote called Validation, Verification, and Monitoring of Cleaning in Food Processing Factories. So really catchy title, huh? Yeah, probably could have put more work into that. Anyway, the article is fantastic. It's gotten some good attention. I think it's a culmination of a lot of things that really smart people have taught me. In there, I spend some extra time talking about SSOPs, these sanitation standard operating procedures. One of the career limiting mistakes I made while I was a factory person was having SSOPs that were crap. And that's using a generous word. They were copy and paste of each other, basically. The only thing different from one piece of equipment's SSOP to another was the title at the top of the page. It basically said something like, do a dry pickup, rinse the equipment to the floor with a hose, apply foam, let it sit for 10 minutes, rinse, apply sanitizer, call QA. That was essentially the instruction to the employee for every SSOP in the book. Kind of no doubt I had a lot of variability in the cleaning outcomes. If that was a cake recipe, it would be the equivalent of mixing your wet ingredients and your dry ingredients together in a bowl, put it in a pan, bake it, enjoy. That kind of a cake recipe would deliver, I don't know, if you did the recipe, you might have a 7-tier wedding cake, and I would have a charcoal briquette and a call to the fire department. Wouldn't it give me more predictable, repeatable results if that would have been like a true Betty Crocker cake recipe on steroids? Mix 3 medium eggs, 2 cups of sifted pastry flour. Here's a video on how to measure sifted pastry flour. Divide it evenly into 2 9-inch round cake pans by weight, and here's how you do that, and the scale setup, and what the batter should look like after it's mixed, and all kinds of things that could drive out that detail. Then you and I, if we both followed that, we would have had essentially identical cakes. Our cleaning procedures for our freezers and pretty much everything else, especially when we're dealing with a risk that we're trying to reduce, should have that level of detail. But in addition to that, we really need to spend some time understanding how clean we need to get it. What is success? Sanitation's got an idea. QA has got an idea. Maintenance probably has some ideas of what they want cleaned. Engineering probably has some things. The equipment manufacturer might have some stake in that. Chemical supplier. Don't forget safety. Safety's probably got some things they want to deal with. So agree on what success is. If you are a big old Dwayne, you think you know it all, and you're going to come up with some success criteria, I guarantee no one will agree with it. In fact, over time, I doubt you will agree with it. You'll compromise. You'll generally drop your standards just a little. I don't mean to be insulting, but that's what a big old Dwayne does. So don't do that. It's career limiting. Drive out that variability, which is our enemy. And when it comes to cleaning, variability is the enemy. Drive it out using detailed SSOPs that will deliver when executed as written. Consistency and predictability. That's just key right there. So this is what drives effective cleaning. And I would encourage you to look and see, do you have Dwayne type of SSOPs, or do you have a Betty Crocker SSOP on steroids? The former is going to be career limiting and probably causing you some problems. Okay. That's effective cleaning. Now let's talk about sanitary PMs. So sanitary PMs are kind of interesting. These are the stuff that not necessarily maintenance does. It could be operations, it could be sanitation, it could be, engineering. There's a lot of these preventive maintenance things that get all lumped together. But the point is that it really starts with good inspections. It's got repair and replace elements in there. It's got non-routine cleaning, stuff that you don't do every time. You can have that deep clean, or some people call it structural cleaning. These all make up sanitary PMs. These need to be conscious decisions that that have documented procedures. That documented procedures needs to include, what am I looking at? How often do I need to look at it? But here's the important one: what's the standard? What does good look like? What does it look like when I need to repair it or replace it? And when it comes to the cleaning aspect of it, again, do I have an SSOP? These non-routine cleanings and deep cleans, these structural cleans, happen infrequently. If you have a lot of variability in there, you got to live with the results until the next cycle, or you're going to have to redo it, and these are usually a little arduous. So, schedules. Having things on schedules. This goes beyond the how often necessarily. It's predicting maintenance. It's predicting when do I need to do things. I like schedules. I like master sanitation schedules rock. These things are fantastic tools that I can use to plan, so that I make sure that I've got resources and equipment and line time, and master sanitation schedules are just one of those things that are really powerful tools for us. I got so excited about master sanitation schedules that, well, let's just say, no matter how good of an idea it seems like at the time, never offer to make for your wife a master sanitation schedule for the housework. So, really bad idea. Yeah, she might remind you of that 35 years later while you're scrubbing the shower. Right on schedule. Yeah, so, sorry, we're talking about freezers. KPIs on freezers or on our sanitation schedule. So what's our percentage of completion on time? That's a really good KPI. And whoever's got the responsibility for that program should be standing up in front of a group of people reporting on that. This is the percent I'm at. It's a good way to drive improvement and keep people honest. Okay, so that's effective cleaning, sanitary PMs. Let's talk about hygienic design. So that's that third element in increasing our capacity to cope and thereby reducing our risk. So the AFFI Listeria Control Program has got a section on hygienic design. In there is 2 sanitary or hygienic design checklists. These 2 hygienic design checklists were proudly borrowed from elsewhere. They might look familiar to a lot of people. And we've housed them here because they were free and public, and they are the finest summary of hygienic design principles that I've seen. One checklist is for facility, the other one is for equipment. I would encourage you strongly to look beyond just the equipment. Do the one for the equipment, but if you have really good equipment in a really crappy environment, you're going to have bad results. If you've got really bad equipment in a really good environment, you're going to get bad results. You need to have both, and oftentimes we forget to look at the facility. We focus too much on the equipment. Not that that's bad, it's just you need to look at the facility as well. Do not be a big old Dwayne and do these by yourself. You need a cross-functional team. That way you learn from each other and you start to pick up on some of the emphasis that your colleagues would have, and everybody gets smarter. Understand that when you do these on new equipment, any gaps that you find, you can play rock, paper, scissors with the company that's building it for you and your budgeting folks, the folks with the checkbook, and see if you can engineer the stuff out before it gets to your factory. That's a really good way to do business. Because if you don't, you're going to have to live with that. You're going to have a program in place to address the gap for the life of the piece of equipment. That's a hard way to do business. It's very expensive over time, especially with freezers that we tend to run a long, long time. If it's existing equipment, however, then you're really forced, when you find gaps, to put programs in place to address the risk now, while you try to come up with engineering solutions to design that out. The point is that you're never going to have a perfect hygienic design. At some point, you're going to have to put programs in place to address the risks. So sooner rather than later. So if you've identified a gap, you need to do something immediately. You can't just say, I'm going to wait until I get an engineering solution. That's a really hard thing to explain to a judge and a jury and a prosecuting attorney. Once you've identified a gap, you need to address it as soon as prudent. So, and that's as soon as possible. Okay. Understanding there's no such thing as a perfect hygienic design, especially when it comes to freezers. These things are horrible for hygienic design. The hygienic design checklists have 12 categories in it. We're going to just touch on a few. Accessibility is one of the categories. So accessibility for hygienic design, these freezers, the picture that's on this slide is a very narrow view of a small portion of what could be a huge spiral freezer. I've been in spiral freezers that are 3 stories tall. You probably have, some of you on the phone, maybe you have bigger ones than that. These things can be huge, but they're all roughly designed the same, the spiral freezer. Accessibility is a real problem in spiral freezers, as those of you who own them know. For example, the different layers. So this one is about face level for the QA tech in there. The one above it is over his head. The one above that, you need a ladder for. The 110 above that, you need a lift, and fall protection, and it's just a real pain. Inside the center drum this is a drum, and the conveyor is literally dragged around the circumference of that drum. In that drum is all the support framework and such, and it's really, really, really hard to clean in there. It's hard to get in there and inspect. Okay. Niches. A niche is any place where 2 pieces of material are put together, like the nylon wear strip on this support rail. It's a really good spot to find Listeria, incidentally. Or those nylon wear strips at the center of the drum, which are really, really hard to get to. How about hollow areas? So I could make a joke about the area between my ears, but I won't. Hollow tubing, hollow framework. There's a lot of things, like the walls of the freezer are essentially hollow. They've got insulation in them, but for all intents and purposes, it's hollow. Oh boy. Collection points. Any horizontal surface becomes a collection point. So here's just a couple of horizontal surfaces. Look, we just went through, 4 categories. And look at all those arrows on that small of a section of a freezer. Just a wee bit of some programs in place to address risks. It's huge. And then there's the sanitary operational performance. Last time I checked, I think I heard somebody say that there's sometimes frost inside of freezers blowing around. Yeah. No, it's always the case. And so you got frost, you got crumbs, high velocity fans blowing things around. It's really, really tough. So what do? You don't be a Dwayne and wait for the gaps to show themselves by having product that's out of spec. Or an inspector going in and going, what the heck were you thinking? Instead, find the gaps using the hygienic design checklists and address them ASAP while you wait on engineering solution. So know the gaps. Have your eyes wide open to the things that are a risk. Okay, again, the Listeria control program's got some good information in there on hygienic design. And I hope you're seeing in the picture, none of these pictures are Nestle factories, just an FYI. All right, we could have talked about hygienic design for several days, but instead we're going to move on and talk about environmental pathogen monitoring. Okay, I don't like the term pathogen monitoring. It's not really monitoring, it's verification as far as I'm concerned. We're verifying the prerequisite programs that influence pathogens in our factory. Hygienic design, sanitation, hygienic zoning. There's a lot of stuff that influences the outcomes of our pathogen monitoring. Don't like that term. Okay, I'd ask you to look at the Listeria control program, the AFFI freezer management guidelines. That's a pretty good document. I had just a little bit to do with writing that. The pathogen monitoring program, some good guidance with some best practices in there. So take a look at that. Here's what I want you to think. I want you to believe with all your heart that your freezer has Listeria in it, and I want you to act like it. American jurisprudence says you are innocent until proven guilty beyond a reasonable doubt. When it comes to Listeria in your freezer is guilty until you prove that it's guilty. You need to act like your freezer is contaminated because it probably is. You just may not have found it yet. That might be insulting to some people, but honestly, if you go at it with that kind of an attitude, you're going to protect yourself. Because if you know that there's Listeria in there, you're going to keep it from spreading out. You're going to have barrier controls about going into the freezer and coming back out of the freezer to keep it from spreading outside the freezer, to keep it from spreading to the product, and then also to keep you from accidentally bringing a contaminant in there into the freezer from outside the freezer. So treat your freezer like an isolation tent for people with Ebola, radioactive Ebola. You don't just walk into that tent. You do some very particular things before you go in. And when you come out of that isolation tent, you do some pretty particular things coming out. That's the way you need to treat your freezer. Because there's a lot of people going in and out of those freezers, bringing a lot of tools and sanitation equipment and shoes and wetsuits and uniforms and testing supplies for the lab. It's holy cow. There's a lot of stuff going on in and out of that freezer. Okay. Sampling. I want you to try to find it. I want you to try to find the contaminant that's most likely in your freezer someplace. If you believe it's in there, you will try to find it, and you should celebrate when you do. I mean, celebrate. You found it before your consumer or a regulatory agent or your QA group or somebody else found it. Murphy's Law says if you don't find it, somebody else will. So celebrate if you found it early. That is a great thing. I mean, you bring in pizza, you get company store coupons or something. So if you got unwrapped product in your freezer, there's a lot more risk. Therefore, you should probably do a lot of sampling on the inside of the freezer. And then, because you want to find it. You want to find it before it can get to the product. You want to find it before it can get tracked out of the freezer. So you're going to spend some extra time in there really looking hard. And then you're going to sample outside the freezer too. That's a good idea because you don't want it to travel upstream or downstream from that freezer. You don't want it contaminating other areas. If you got wrapped product, I think it's a good idea to still sample on the inside of your freezer because you don't want it tracking out or contaminating exposed product upstream of the freezer. So sample some inside, some outside. So the difference is that unwrapped product. You just really want to make sure that you've got that well under control. Now, Sanjay at AFFI asked that I spend a little bit of time talking about this next topic, and I'm going to only just touch on it, and it makes me kind of nervous, but some factories apparently really rely heavily on finished goods testing. and not so much on the upstream process. That's really dangerous. Now, there's a lot of implications to sampling other things besides finished goods. There's a lot of implications. I'm not telling you what to do. Please do not misconstrue this. I'm telling you to have a discussion at your factory, in your organization, about what are all the ways that we can catch it before it gets to the point where it's contaminating finished goods. Chances are there's smoke before there's that fire in the finished goods. Can you pick up that smoke with a sampling program upstream? All kinds of ways to possibly do that, like food contact surface and product residue sampling for indicator organisms, but you need to have that discussion, I think, in your factory. If you're relying really heavily on finished goods testing, there's probably some things that you could do that's pragmatic, of low risk to you and your organization, but again, better protection for your consumer and your product and your brand. So just have the discussion. This was Dwayne's opinion only, and you know what a big old Dwayne kind of decisions he's making. So just have that conversation in your factory, okay? What do you do when you get a positive? Well, you run around with your hair on fire and make your way towards the exits. No, you don't. There's corrective actions, there's preventive actions. So one of the corrective actions that I see commonly is re-clean, re-sanitize, retest. I don't like that. But what I like and don't like is really irrelevant. Instead, I think if you look at your positive, like a crime scene, you're going to do, a crime scene investigation. What crime scene investigator goes in and cleans up the crime scene before they do their investigation? That would be a big old Dwayne doing that. No, that doesn't tell you anything. You've just destroyed all the evidence. So rather than go in and clean and re-sanitize and retest, you should go in there and put up the police tape, crime scene tape, don't cross, you quarantine. Wait a minute, we were talking about quarantining earlier, weren't we? Nothing in, nothing out. You get out the DNA tests and the fingerprint tests, and you talk to witnesses, and you get the magnifying glass out, and you look at the crime scene and all the things that happened. Like my housekeeping style is, there appears to have been a struggle. This kind of thing is what you really need to do before you go in and do the cleaning and disinfection. If you have a procedure for when you get a positive, follow that procedure. It should follow this kind of three-step process. So quarantine it, investigate the snot out of it, interview all the witnesses, do a thorough investigation of the crime scene, then go in and clean up. Okay. You might have to, if you've got a stubborn positive, you keep getting positives, you might need to do some structural or deep cleaning. I don't know what you call it. And then there's the atomic bombs you can throw at it. If you get a positive, there's chlorine dioxide gas, ozone gas, hydrogen peroxide gas, heat decontamination, which is really hard on equipment, but these are things that if you haven't gotten to root cause, they'll buy you some time. But you'll generally find it again because you didn't find root cause. It's just these chemical and heat decontaminations are kind of like putting on deodorant instead of taking a shower. So it's treating the symptoms, not always getting to root cause. Okay, so now you think you got it under control. Your testing keeps coming back negative. Life is getting kind of good. We need to kind of do an after actions review and try to keep it from happening again. So what was it that caused the failure? Was it cleaning that needed to be more effective? Maybe the SSOP needs to be adjusted. Maybe we have better sanitary PMs. Anyway, this is starting to sound familiar. Isn't this what we were doing to reduce our risk? Yeah, there's the hygienic design. So it could be any one of these things that, or any combination of these things that needs to be adjusted. So think of those as the long-term solutions. Okay. Watch-outs. This is kind of fun because, man, we've all got some good stories about stuff we found in freezers and where it was and the process we took to finding it. These are just me, okay? So, and some of the folks that I've dealt with, I'm sure you've got some great stories and watch-outs that I wish I could share. But traffic, again, this is that quarantine thing. We sample in our factory environments the floor drains, right? Freezers oftentimes have drains. What a great collection point. Conveyors extend beyond the walls of the freezers. So sometimes these freezers can spread contaminants out from the freezer because the discharge of the freezer and the infeed of the freezer extend out. So, and not only can they bring contaminants out of the freezer, it goes both ways. You can be bringing contaminants in the freezer. Don't forget the top of your freezer. A lot of times there's some refrigeration pipes up there that are frosted. And the last time I checked around the ceiling in most factories, it's just a wee bit warm. Okay, it's really hot. Makes for puddles, sometimes a lake. There's penetrations through the roof of that freezer. You could also have a roof leak above that freezer and not know it. And the only thing that's sealing up that penetration through the top of the freezer where pipes run in and out, conduits and such, is some caulking. Oh, crap. That's not good. Because caulking, welds, and seams oftentimes fail in these freezers. Well, I've had maintenance people tell me it's because of the high pressure hoses from sanitation. No, it's not. It's from the temperature differential. These freezers run around, give or take 10 or 20 degrees. They're like minus 30 inside. And then what do we do when we clean them? We heat them up to 130. And remember earlier I said, don't clean your freezers more than you need to because it destroys them. That temperature delta between operation temperature and cleaning temperature, minus 30 to 130. That's how many degrees is that? That's like minus a minus. That's like 117 degrees. It's a huge number. That uneven expansion and contraction will destroy seams. Destroys a lot of stuff, but the seams, the caulks, the welds, it just opens them up. It peels away the caulk, and now water can get in there. If water gets into those areas, that's bad. That's a great place for Listeria to grow. And then when we start the freezer back up, it freezes that water. Frozen water starts to expand. It pushes the seams apart even further. And, well, you ever put a bottle of beer in the freezer and forget it? And the next day you open the freezer and you look and the beer froze, it popped the cap off, and now you've got this beer sickle sticking out of the top of a beer bottle. The beer sickles aren't bad on a hot summer day. Yeah. Kids don't care for them at all, though. Wait a minute! Don't give beer to your kids. Please don't call Nestle again. Anyway, coming up out of that gap in the freezer panels in those seams, now you got a Listeria sickle. Did I mention there's high power fans and blowers in there blowing stuff around? Oh, what could possibly go wrong? So watch out for those frozen seams and the swollen panels and such that you'll see when water has gotten into them. Now, I'm not talking frost around the openings of the freezer like at the entrance and discharge. But like in the middle of the side of the freezer, you'll see frost. And that's just a very efficient temperature transfer, typically through a saturated panel or seam. So if you've got frosted panels or frosted seams away from openings, chances are we got water in there, and that's just a great place to look for Listeria. Refrigeration coils and fans and condensation drip pans inside the freezer, of course, those are collection points, and good places to sample, and they're really, really hard to clean. Soft metals are present in most freezers. That's really tough to try to clean a corroded surface. Okay, grease, chain sprockets, bearings, wherever there's grease, oh man, it's really easy to find Listeria hidden in that grease. It's like a biofilm on steroids. So it really protects Listeria. And honestly, some of the greases are vegetable based. So the Listeria doesn't just, reside there, it can grow as long as it's got some decent temperature. So think about grease. That's just all I can say. And then there's foreign material risks in there too for a lot of things with belts and guides and wear strips. But this picture in here, this is not a Nestle factory, but it drives me crazy. So this guy is going to create the next hair complaint. I didn't think that we could wear our hairnets over our ears anymore. That was bad. I can clearly see his eye, which means he's got some lousy safety glasses. The guy's freaking armpit is on a food contact surface. His sleeve is across the food contact surface, but he's wearing gloves, so that's okay. I think fewer than 50% of our factories have done micro-challenge studies on smocks. Just saying. So we wonder how microorganisms move around. Here's a really good way right there. And this is a QA person. Way to go, QA. Okay, and then I think about it, I sure hope that conveyor's locked out, because if it isn't and that starts up, that lab coat is going to take him for a ride up until the next support post, and then things are going to get really ugly for him. And let me tell you, freezers are a very lonely place to be if you're injured. They're kind of soundproof. You can scream in there a long time before anybody finds you. I would recommend buddy system, but this is not my area of expertise. It's just something that scares me. Okay. A few more watch outs and then we're getting pretty close to wrapping this up. Frozen thawed interfaces. So inside of the freezer is really cold. Outside of the freezer, not so cold. Somewhere there's water. Water is to microorganisms what gasoline is to fire. This is where you're going to find organisms prevalent. They're going to contaminate conveyors, product possibly, the environment. Just pay attention to these. Condensation is a bad thing. So I like the entrance to this freezer. It's got a sloped flashing over or pan over at the entrance, hopefully at the exit as well. That channels the condensation away from the product. That's a good thing. That flashing over the product zone. It's usually sealed with a bead of caulk. And remember the expansion and contraction problem? Yeah. A lot of factories don't realize their door on their freezer is heated. I just found out that not too long ago that my refrigerator and freezer door at home has a heat strip in it. I didn't know that. Yeah, okay. Don't be a big old Dwayne. Anyway, that gasket is a hollow rubber gasket and nobody ever cleans it, I think. And you step right over the threshold where it's making contact and in and out of your freezer. What could possibly go wrong? Lights, conduits, and electrical boxes. A glass of iced tea on a summer day sweats on the outside. It's delicious. It sweats on the outside. So when you've got really cold and really warm, the condensation forms on the warm side. Lights, conduits, and electrical boxes. Lights and electrical current generate a little bit of warmth. So wires running through conduits, switches inside of electrical boxes, and light bulbs and light and the ballast inside and so on. This is generating just a wee bit of heat. Not a lot, but enough. So the condensation forms on the warm side, which is inside the conduit, inside the electrical box, inside the light. Oh boy, what a rough place to be dealing with Listeria. All it takes is one organism in there, and now you've got a pretty nice place. So make sure that you pay attention to that with your sampling program, and possibly as an investigation on a positive in the environment in your freezer. Okay. Insulated metal panels, they even give them an acronym, IMP. These insulated metal panels are corrugated, and we butt them up against flat flashing. So we've got a seam between the flat flashing and the corrugated metal panel, so our seam becomes a gap, no gap, gap, no gap. Then they fill it with caulk. Did we talk about caulk? Yeah, I think so. Downward facing caulk is just a wee bit of a problem. Upward facing seams, like flashing over an opening, that's a bigger problem when that caulk fails. Then the water sits down in the channel and bad things happen, and it's right over the product zone. So these are some watch outs. Just some of them. Like I said, you folks probably have lots of them yourself. These are the ones I'm aware of. Might help you. You could probably add to the list. All right. There's what, so what, and now what. So we've kind of covered the what, freezer sanitation and the risk mitigations and things. So what, we've talked about the risk, again, to the product, the consumer, and the brand. So now I want to just give you some homework. The now what? Now that you've listened to me ramble for a while, what's a good idea for you to do? I'd say get back to your factories and look at the cleaning, the PMs, and the design of your freezers. Make sure that your cleaning is under control, that you've got good SSOPs driving your outcomes of cleaning so that you can have a good, stable process. Make sure that your sanitary PMs are adequate and on schedule. Do you have a KPI? Do you have the infrequent cleaning documented well? Are you aware of all the sanitary design gaps that your freezers and other equipment in your factory, but in particular your freezers, have? Do you have programs in there to address the risk, or are you being a big old Dwayne waiting for your finished goods to be out of spec to go and do your research to find the sanitary design flaws? I'd recommend that you're proactive instead of reactive in that regard. And then your freezer's contaminated. Just act like it and go on a seek and destroy. Quarantine that so you don't accidentally bring the contaminant in. And certainly that the known contaminant, even though you don't know it necessarily, but you're acting like it so that it doesn't get out. What are the appropriate barriers and routines for all the things that happen going in and out of your freezer? And then that environmental monitoring based on risk. So if you've got unwrapped product versus wrapped product, if you've got a history that's a little greater than others, if you've got some significant design flaws, etc. So make sure that you're trying to find Listeria. If you're not trying to find Listeria, you won't. If you are trying to find it, you're going to celebrate when you do. And it's going to be a woohoo moment, and there's going to be pizzas and whatever. Okay. How about that? We're already on to slide 15. We talked about where to find more information. We talked about why you're cleaning. So make sure that you really have a good cleaning objective that everyone agrees to, not just you. You're reducing risk by increasing your capacity to cope. You're acting like your freezer is contaminated, because it probably is. You're using a seek and destroy attitude around your pathogen monitoring. And now maybe you've added to your list of things that you've seen go wrong or heard that can go wrong with freezers. And then we talked about making sure that you apply these things so that you have even more control than you already have over your freezer. I'm tired, but I had fun. So I'm going to turn it back to the moderators and see if we've got some questions.
Thank you, Dwayne, for that excellent and often humorous presentation. Did very much enjoy it. It was like listening to a podcast. I loved it. I'd like to open up the session for questions. It looks like we had several that actually already followed Sarah's earlier directions of writing your question in the text box of your GoToWebinar control panel. And we already do have some waiting for us right now, Dwayne, so Sarah's going to read some of those for you.
All right, Dwayne, so this question is, you mentioned that hygienic design is a really important factor when it comes to hygienic design, excuse me. At the same time, you mentioned that cleaning a freezer frequently will damage the freezer over time. So how can we cope with a poorly designed freezer, the need for sanitation, and a company not ready to invest in a new hygienically designed freezer?
Wow. All right, if I could probably solve world hunger, if I could come up with a good one-size-fits-all answer for that. This is the age-old question. So when you've got a known hygienic design flaw, you put programs in place to address the risk. Some of that is modified cleaning. Some of it is these sanitary PMs. So you're going to do a cleaning validation and routine verifications. You're going to be monitoring against your cleaning. This is going to show you, am I cleaning too often? Can I cut back on the cleaning and therefore slow the damage to the freezer? What kind of corrective repairs can we do while we're trying to make sure that we're staying food safe? So we're going to be testing like crazy because old freezers are going to have Listeria in them. I don't have a better answer for you except make sure that you've got the best cleaning process and the best frequency that you can have to slow the damage, and then whatever you can do to try to get some of the damage corrected. So the equipment manufacturer, if they're still in business, can help with trying to determine what that looks like. But honestly, that is a really difficult question. Gather the data that you need through how much extra effort this is, how much extra sampling, how much extra risk you've got, how many positives you're getting in the freezer, and take that to your factory manager, your company owner, and stand on their desk and put footprints on their desk and tell them we got a huge risk. If we don't do something about it soon, it's going to get really expensive. The last thing you want to have is a recall. So throwing product away, one good long run of product buys a new freezer. So I don't have a good answer for you, and it's very situational, but that's an age-old question.
Yeah, I think you're right, Dwayne. I think when we've been trying to give that same advice to QA professionals is arm themselves with the financial, the ROIs, because that tends to communicate the best in regards to need for any new improvement, but particularly I think, like as you mentioned, that the freezer is a big investment. So, should we do have another?
10 minutes after this webinar, I'll think of a better answer.
We do have another question for you.
So, what type of belting options are there for IQF freezers?
That would be an equipment manufacturer's suggestion for you. You know, if it's little small particulates, it's going to be different than, big chunks of stuff. So, and if it's a spiral freezer, it's got to be able to bend and flex in all directions. If it's a bookshelf freezer, then it's a different animal.
So is it your opinion, Dwayne, to potentially, get second opinions from equipment manufacturers? So, like, if you're using an equipment manufacturer, you have questions, should you go out and ask another equipment manufacturer an opinion on those kind of things to back up the position?
So if this was not a webinar, I would turn this back to the participants and say, where are all of your resources to get information? So internal and external networks. So maybe talk to somebody at AFFI, possibly equipment manufacturer, possibly your chemical supplier, possibly the engineering group. Don't be a big old Dwayne and just make a unilateral decision thinking that you know the best thing. You're already in a network here. So utilize the internal and external networks that you've got, and not just one person's opinion, because that's a little dangerous. That's what Dwayne would do.
We're going to do one more question, Dwayne.
Sure.
And that would be, has fogging with PAA or QUAT, is it effective in your opinion?
Okay, there's some good studies out there that have shown the absolute waste of time that fogging does. Gas is another animal. Fogging and gas are so different that particle size in fog is like the particle size would be equivalent to the Empire State Building, as opposed to gas, which would be the size of a ping pong ball. So chlorine dioxide gas and the different types of PAA things that you can put into gas form is way different than fog. Fog settles too much. You don't get good contact time. It's very much saturation in front of the fogging nozzle, but once you get away from the fogging nozzle, there's not enough contact to really prove to be effective. There's some good studies out there if you want to go Google fogging efficacies. It really doesn't matter what you fog with. It's not very effective, but it makes people feel good. Gas is another story. So, you know, when you sanitize, you got to have contact time, right? That's usually like 10 minutes, and that's the efficacy. Fog, you never get that. Plus, it's dangerous. I just don't like having people exposed to airborne chemistries. So, I don't like it, but it makes people feel good. So maybe there's something there, but as far as efficacy, I don't see it.
That's great. We do have a lot more questions, but we're gonna, Dwayne actually, before we started, indicated he'd be able to answer some of these questions as long as he didn't get 200 or more. So it doesn't look like there's that number, but there are a few more that we can't get to based on the timing of this. So do appreciate your willingness to take a few questions, Dwayne, and thank you for your time. I'm going to turn it over to Sarah to close us out.
So thank you again, Dwayne, and thank you to all of you for joining us today for our webinar. As I mentioned previously, the webinar presentation slides and recording will be distributed to all of you after this webinar. And again, as Donna mentioned, we did not have time to address all of the questions, so Dwayne has kindly agreed to answer these questions. So stay tuned for those questions in a follow-up email. So thank you again for joining and have a great day.
Thanks, Dwayne.
Thank you.